All right, welcome. And the reason we're all here, right? That's why we're here, is because of the reason why we're here. How the hell did we get here in the first place? Right? And what and who are we? And how did the universe get here? And how did the universe start? And how does the universe work? And where is it going? You know, where are we physically going in the universe? What's going to happen to the universe down the line? What's God? What's up with consciousness and spirit? You know, all these questions, major, biggest questions you could possibly ask, have been asked since the origin of human consciousness. And we've been trying to answer these questions the best we can, grasping at our perception of reality and trying to gather it together to get some sort of comprehensive understanding that we can actually sink our teeth into, that we can actually explain and have an understanding of where we are, how we got here, and how we fit into the big picture. For a very long time, these questions were answered in a philosophical, religious, spiritual, intuitive kind of way. In other words, I don't know, but it seems like this, or my guru told me this is the deal, or Jesus or Muhammad or Buddha say this is the way it goes, so I'm going to listen to these major figures of major religions, right? Then much later in the evolution of consciousness, we invented a way of knowing things that starts out with the same premise, I don't know. So how am I going to figure this out? I'm going to gather as much data and as much information as I can, using as much technology as I can, including my own senses and anything that aids my senses. If it makes sense and it matches my hypothesis, I might think that it's correct. That's the scientific method, right? Scientific method has not been around for very long. But in the evolution of the scientific method, we have new understanding, building on new understanding, building on new understanding. We have this thing in human being life, which is different than any other creature on this planet, called collective learning, where we can write down what we've learned. And then after we die, the stuff that we've learned stays. And the people that were born after us can learn from what we learned. And so we're gradually building on all this information that's been gathered since the beginning of writing down or noting information that we've collected. And in the series of the scientific method, sometimes we get to a point where we're like, okay, now we figured it out. Now we actually understand what's going on. Here's our base level of understanding. Call that the standard model, if you will. Standard model could be the standard model in any line of research or line of understanding. But there's this one way of understanding things called physics, right? Physics is, I don't know, but I'm going to try to figure out how the universe works and describe it in a very specific language called math. Math is this language that every kid on the planet has to learn in school, no matter what country they come from, because it's a universal language. And that's the language physicists are using to describe processes that they observe in nature, trying to come up with a fundamental set of equations or a set of math or a set of understanding that describes the entire universe. We've been trying to find one set of math, one set of information that describes the entire universe no matter what. I don't care if you're talking about galaxies or clusters of galaxies, or if you're talking about quarks or this God particle that just got found, quote unquote God particle, right? The Higgs boson got found last week. We've been looking for it for 40 years, right? So now it's a very interesting time to be talking about unified field theory, because now all of a sudden, and I'm sure Time Magazine's going to have this on the cover like in a few days, it's going to be all about the universe. How does the universe work? Where did it come from? Super epic time right now, because after all this process of understanding stuff and us being a little vague, now we're starting to splice matter down and look at the universe in such a detailed way that we're looking at stuff that's billions of times smaller than the atom. When we first found the atom, we thought we found the smallest thing the universe does. We've been saying that for a long time. Oh, we found the universe the smallest thing. It's called cells. Everything's made of cells. Sweet. And then not very long later, excuse me, we found something billions of times smaller than that. Excuse me, we found something billions of times. It's going to keep happening like this. And so we have this series of scientific understandings, getting a paradigm, and then sometimes some individual person, like Galileo or Copernicus, comes along and says, I know you guys all think it's like this, but I think it's like this. And it doesn't always go over very well, right? Like that person sometimes is ostracized, even threats against them and stuff like that. Pretty brave individual who comes around and says, even though this evidence points towards this model looks correct, this could be a different model. And that keeps happening over and over. And those people start out being thought of as, ridiculous, and then it turns out that they are thought of as being correct. And this paradigm keeps happening over and over. I've been reading about this stuff for a really long time, and a disclosure right off the bat, I am not a physicist. okay? And I'm not a mathematician. But I can tell a story. I can explain something that's easy to explain and easy to understand. And so that's all I'm doing. I'm doing this because, like you, I've been asking these questions. Somebody a long time ago said, oh, it sounds like you'd be interested in this book called The Dow of Physics. Anybody read Dow of Physics? Yeah, Fritjof Capra, 1977 or something like that. Advanced physicist who understood, quantum mechanics and string theory, the very origins of string theory, and started to realize that Lao Tzu, out of ancient Chinese information, was matching the same thing that Einstein was saying. And there's this one page in that book where it's a quote of Lao Tzu and a quote of Einstein on the same page. And I went back and forth. I'm like, wow, Lao Tzu and Einstein are saying the same thing. That must point to some really super fundamental, base level of reality. I'm going to look into this. So I read a whole series of books starting about 20 years ago, including Dancing Woolly Masters, Elegant Universe by Brian Greene, Brief History of Time by Stephen Hawking, all these books for the layman, because I am a layman, right? I don't understand these equations. You got to explain to me what this equation says. And then I was like, okay, that's interesting. I'm getting this. And then somebody's like, oh, you should meet my new boyfriend. I haven't seen you in a while. It's my friend Amber. His name's Nassim Haramein. And he's doing a presentation at this festival that we're at. I said, oh, cool, I'm going to go see this guy. And when I saw Nassim Haramein, I got blown away because he said everything that I had heard before, and then other things. And then he said some stuff that was so out there, so off the wall, so different than anything else that I had heard. It was as if he told me that we lived on a sphere, even though obviously we live on a flat planet. I mean, for a long time, you could go, here's my hypothesis. We live on a flat planet. I'm making an observation. There's the horizon. It's flat. So therefore, it's pretty solid. And we have this model that shows that if this planet does this curlicue and does all these crazy things, all the observations I can make match my model that shows and proves that the Earth is the center of the universe and it's flat, and you better not go off in your ships too far or you're going to fall off the edge and the monsters are going to eat you. And the church was saying, this is the way it is. We're the center of the universe. It goes God, humans, plants, animals, plankton. There's some sort of hierarchy, but we're as close to God as you can get, unless you're the Pope. If you're the Pope, then you're a little closer to God, so you should listen to the Pope, right? That was the deal. And then Copernicus and Galileo come along and say, actually, I think it's different, and it didn't go over too well. Galileo almost got burnt at the stake. Luckily, the Vatican even is evolving their consciousness, and they have formally excused Galileo. Unfortunately, it took until 1992, you guys. So the process of us changing our paradigm from the old model to the new model doesn't exactly happen quickly all the time, but we're starting to see it happen more quickly. The time period that it takes to transfer to the next model is getting smaller and smaller as our technology and our consciousness and everything else is going off the chain right now, exponential. And so Nassim Haramein, in my mind, is one of these guys that is flipping the model around and saying something very different. And every day there's new discoveries that are confirming stuff that Nassim has been saying. And I would say the discovery of the Higgs boson is one of those things. And we'll get to that. This poor guy, too, had a hell of a time because we thought we understood space. We thought we understood time. And then this guy comes along and says, no. You guys got it all backwards. Space and time aren't separate things. It's called space-time. There should be a little dash in there. And people are going, what are you talking about? He made these crazy predictions that sounded totally out there. And not very long later, actual science was done to prove that he was correct. And the guy that couldn't barely graduate from college and when he did got a gig as a patent clerk became Time Magazine's Person of the Century, smartest guy that ever lived, most respected scientist in the history of science. Okay? So when I saw Nassim Haramein speak and he said stuff that reminded me of what Galileo and Einstein were saying, because what he was saying was so outside of the standard model, I thought, well, first of all, this guy could be totally crazy. If he happens to be correct, however, then it goes Galileo, Einstein, Haramein. Like, he's on that level. Because he writes the math that the physicists write, advanced equations, and Nassim considers himself a mystic. He looks at every possible information system there is. Doesn't matter where it comes from. He'll go for every religion, every ancient civilization, crop circles, doesn't matter. All that information, it's all valid information. And he starts to look at all the different connections and he connects all the dots. And so that's what I'm going to do here is I'm going to give you a very brief Reader's Digest version of the cliff notes of the Reader's Digest version of this theory. Because if I had unlimited time and I was to sit here and talk off the top of my head with all the information that I could deliver to you right now, I could do 10 hours a day for a week. Seriously, I could talk for 70 to 90 hours probably. That's how much information there is. My normal come and get the super dense download thing is 3.5 hours. This PowerPoint takes me 3.5 hours talking as fast as I am to get in all the information. I have 1 hour, okay? So it's the Reader's Digest version of the Reader's Digest version. So what I'm going to do is basically explain to you what unified field theory is and the big implications and the kind of framework that we're in, and I'm going to have to skip a massive amount of detail. And hopefully at the end of another 45 minutes, you'll have some sort of vague understanding of what this body of knowledge is. Because when you're trying to talk about the entire universe and everything in it, by definition, it could take forever, right? And we don't have forever. So you have to very carefully choose what part of infinity are you going to talk about, all right? Because the universe seems fairly infinite. You know, there's a lot of theories out there that say the universe is infinite. And talking about infinity in itself is an infinite process. So keep that in mind as I cruise through some of these slides really quickly. Nassim Haramein starts at the base of the foundation of the Standard Model because he knows, and all physicists will tell you this, we have this model for reality that's called the Standard Model. It's very good at describing many things. And then as you get into the fine details of it, it gets a little bit vague and you're not quite sure if it's 100% correct. And so you have to do these experiments and verify your stuff, and then it turns out that it wasn't quite correct, so you have to change your model and kind of put a little patch on it, fix it, and then it gets a little more complex, and then another patch. Now our Standard Model is so complex and so hard to deal with that you have to have practically a PhD in mathematics to even understand some of these equations, stuff like string theory. You guys heard of string theory? Do you guys understand that stuff? Right? That there's maybe like 7 or 11 or 188 dimensions, right? You're like, okay, what are you talking about? Let's break it down like Nassim did. Let's look at the absolute base of our understanding of our reality, which starts out with this thing called the dimensions, right? We take it for granted, oh, I'm going to go see a 3D movie. You know, normally you're looking at flat screen, but if you put these things on, then it looks like it's 3D, right? That's where we live now. Oh, really? How do you get to the third dimension? What are you talking about? Remember geometry class, first day of school? It's a little off the screen there. There's a dot on the screen up there. The teacher will tell you, hey kids, welcome to geometry class, first day of school. I'm going to tell you about the most base level of understanding of reality that we have. It starts with this infinitely small thing called a zero-dimensional point, an infinitely small point in space that has no mass, no volume, no width, no depth, no height, and it doesn't actually exist. It's an imaginary dimension. Oh, really? Teacher, the foundation of our reality starts out with something that doesn't exist? Okay, sweet. That means maybe nothing exists. But then it gets really crazy because quickly they say, oh yeah, if you take a bunch of these non-existent points and you put them in a line like this, now you make a one-dimensional object. Have we seen a one-dimensional object out there? No. Do we have observational evidence for this? No. Again, a theoretical dimension, something that we are inventing in our consciousness to try to make up a story so that we understand what the hell is going on here, right? And then take 4 of these non-existent things, put them like this, or 3, and you make our good old friend the flat plane, like these photographs, right? Flat space. Again, does this really exist? Is there anything that's really flat? If you take an electron microscope to that photo, is it flat? No, it's like the Grand Canyon, right? There's all sorts of contour. If you ask a famous mathematician, like Nassim did on an airplane, how thin are these 2-dimensional planes exactly? Their answer? Infinitely thin. Okay. Infinitely thin flat planes in space. Can we see any of these things? No. Again, this is a theoretical dimension, but check this out. Wave your magic wand over this whole thing, right? You take 6 of these non-existent infinitely thin things and you place them like this, and you've created reality. Ta-da! Oh, really? I'll give you an infinite number of non-existent infinitely thin things. You're not creating reality out of it. And here, are you guys advanced physicists? Is that why you're laughing? No, you're not advanced physicists, and yet this whole room can laugh. That's really sad because our understanding of the entire universe starts out with something that is so non-logical that even us non-advanced physicists can look at it and be like, really? It seems like there's a shred of a chance that this is not 100% correct. If this is not 100% correct, then no wonder string theorists are pulling their hair out right now because they think there's 288 dimensions all folded up into space so tightly you can't even see them. And then you're like, okay, whew, we have gone way out and we're trying to figure out what's going on. I have a feeling we need to go back. It turns out that usually the simplest, most logical, basic understanding of things turns out to be more correct than the complex things. It keeps happening over and over. So Nassim looks at this and he says, I don't know if this makes much sense to me. I'm 9 years old in geometry class, and I know that this is wrong. And I'm going to go home, and my mom is going to kill me when I tell her that I'm going to answer that this is incorrect on the exam because I'm going to get kicked out of school again and keep having to go to farther away schools. This is what happened in Nassim, right? So Nassim says, I better figure this out before I get home from school. And in his bus, on the way home from school, he visualized himself coming out of the bus so high into the sky that the bus looks like a little dot. And he goes so far out that Montreal looks like a dot. Then the Earth looks like a dot. Then he zooms out, the solar system looks like a dot. Then he zooms out, the galaxy looks like a dot. And he keeps zooming out, the cluster of galaxies we're in looks like a dot. Then he zooms out all the way to the point where the entire universe looks like a little dot. As far away as you can get, each scale of these things looks like a little dot. If you zoom back into your body, you're like, oh, wait a minute. Maybe it's like dots, bigger and bigger, boundary conditions, they get bigger and bigger to infinity forever. But wait, what if I flew into my hand in my mind's eye? At a certain scale, you go smaller, then you find the little dots that we're made of called cells, which we thought was the smallest thing, until we went a billion times smaller than that, and we found the atom, and we thought it was the smallest thing. Then we go zooming in there, and we find the nucleus of the atom. We think that's the smallest. Then we find out that there's protons and neutrons, and then we thought it was the smallest. Then there's 3 quarks in every proton. Now we're bashing atoms together with the particle accelerator at CERN, 17-mile circle, 2 miles underground. It's in France and Italy, or France and Switzerland. And you get atoms going as fast as you can, close to the speed of light. You knock these nuclei together, and you create these explosions of subatomic particles. You take pictures at 1,000,000 frames per second and hope that you can see one of these subatomic particles that exists for like a leptosecond, okay? They finally announced last Wednesday, on July 4th, as if to show that the Americans are idiots, that, because remember when they first turned on the particle accelerator and something got dislodged and went at speed of light and bashed all the sensors in the particle accelerator, $2 billion mistake? That was a US company that made the mistake. Yeah. So anyway, so now we think we found this particle that Higgs predicted 40 years ago. That's this little tiny particle that gives mass to all the other particles. And another way to say this, I think, is that they're finding the pixel size of our existence, the pixel size of our universe. We're starting to subdivide matter down to the smallest possible scales we can find. And we're trying to figure out how this all puts together and how this all happened. Nassim looks at this model when he's 9, and he thinks, this doesn't make much sense to me. It seems to me more like that the universe is made up of an infinite number of dots, an infinite number of particles or boundary conditions that are nested inside of each other. Infinitely big ones with smaller and smaller ones nested inside of each other to infinity. That the universe is just simply one giant infinite thing. That is not an easy thing to say when you're a physicist, because you have to prove this. It has to be quantified. If you're a mystic, if you're Lao Tzu or Jesus or Muhammad or Buddha, you can say the universe is infinite. And you can be like, yeah. And I'm intuiting that, and I feel like that's correct, and there's faith involved in that, and it's a spiritual, philosophical, consciousness kind of process, which is a little different than let's take our instruments and write down some numbers and figure this out. Now we're finding that the science guys and the religious guys are saying the same thing in a different way, and that's been happening for only the last few decades. And the speed of the process of our evolution of knowledge is starting to double faster and faster. The amount of information on this planet started to double every decade. Then it started doubling every year. Now I think it's probably doubling about every month.
20 days.
20 days? Oh, cool. It got faster since I last. And so in a month or two, it'll be every week. And then supposedly here by December, the information is going to be doubling every day, every hour, every minute, including our consciousness, our empathy, our love, our compassion for other people. Wouldn't that be awesome? Then all of a sudden everybody's like, oh my God, babies are starving. Wait, I have extra money. Wait, we know how to make food. Bring this food to those babies so they stop dying. I think that's going to happen soon. Don't you think that'd be a good idea? Like maybe we should feed the dying babies first, then build the $10 billion particle accelerator, right? Like maybe we've got our priorities a little messed up. So Nassim is one of these people that thinks that's true. Even though he loves the data that comes out of these things, maybe we should take care of each other first and create less pain and suffering on this planet. I think the bottom line here, the reason I'm sitting in this room right now, is I want to have more fun and less pain and suffering. Simple, right? Isn't it easy? So easy. I always get applause when I say that. What? No, more suffering. I think that we should make the entire planet like Wanderlust, right? Why isn't the entire planet like this festival, right? Where we're all exchanging information and goods and services. We're all taking care of each other. We're eating well. I want to create something that I would like to see called Festival Earth, right? Where each religion is like a different stage with music. I'm going to go to the Hindu stage because they've got sitars and incense. It's awesome. Then I'm going to go to the Jewish stage. They've got people on chairs. They're going in circles. Super cool over there. I mean, the dubstep people aren't gunning down the bluegrass people with machine guns, right? But the Jews and the Palestinians right now, still at each other's throats. Wait, all of a sudden I'm talking about religion and all this stuff? What? This leads to that. And that's the half of this talk that I'm not going to be able to fully get to, but I need to allude to the end, because that's why this is important. Understanding the universe helps you to understand yourself, which helps you to understand all of humanity, which starts to lead towards, wait a minute, discrimination and racism don't even make sense. Why are we even doing that? And then it changes the behavior and it leads to more compassion and more empathy, and then we make Festival Earth out of it, right? So that's like the super reason why I'm sitting here going blah, blah, blah about the dimensions, is that eventually it leads to that. I won't have time to fill in all the details, but this model is explaining non-existence to the fourth mathematically, right? Because you're taking something that doesn't exist and building that something else that doesn't exist, and eventually you get to the third dimension, which is non-existence to the fourth mathematically. So Nassim looks at this, he's like, no, I think this is completely backwards. I think the third dimension doesn't exist, second dimension doesn't exist, first dimension doesn't exist. The only thing that exists is the dot, the 0D. But it's just infinitely different scales, infinitely different sizes of dot. Infinitely big dots with infinitely smaller dots inside of it going to forever to infinitely small. I think most people, when you say infinity, they think of infinitely big things, but infinitely small things exist as well. And infinitely small things exist inside of you right now, which means you have a direct relationship to infinity right now. You are inside of something that's infinite, called the universe. It's a fractal series of geometry, of structures inside of structures, and you're embedded inside that. So by definition, you have a relationship to infinity right now from your current location. If the universe is truly an infinite universe, then one of those possible infinite universes has your heart as its absolute center, which means that you are the center of the universe. But don't forget, very importantly, so is everybody else. Because if you walk into a party with the vibe of I'm the center of the universe and no one else is, people are like, who the hell does that guy think he is, center of the universe? Doesn't go over very well socially. But if you walk into a party, oh, hey, what's up, all you other center of universes? Then you're getting the vibe, and then then it goes much better, right? So maybe we should head towards that. Nassim thinks that there's an infinite number of dots that get smaller and smaller and bigger and bigger. How's that possible? How can there be an infinite number of dots inside my cup of coffee, which is my excuse to take a sip of coffee? I have to build it into the talk because I can't pause for more than 2 seconds. And so how is that possible? How can a finite boundary and infinities be complementary? If you have a finite boundary, and that's supposed to be a circle because it's squished, but say that's a perfect circle, you have space on the inside and space on the outside. So there's information on the inside of your boundary and information on the outside. If you subdivide the space on the inside and put a boundary condition in there, you can get a set of data like the center point of that triangle. And like everything in the universe, let's polarize it and put another triangle in there. Now you have the most common symbol in the history of human culture. You have a series of smaller triangles, another set of information in there. Now that you have smaller triangles, you could put more circles around those triangles. And you could continue to subdivide this space infinitely like this. And you could zoom in on that top structure until it looks like the big one, right? And then tell your computer to chop it down, and then zoom in, chop it down, zoom in, chop it down. As long as you have power running to your computer, you could tell your computer to do that forever. At no point will the universe say, sorry, you've reached the smallest you can go. You can't go any smaller than that. That means inside of any finite boundary, you could chop down that space and get more information out of that system forever. Do you guys follow this? I'm going pretty quickly. Which means inside of any finite boundary is the possibility of an infinite amount of information. Oh, look, I have this thing that seems like a finite boundary called my body. That means by definition, you are an infinite being. And I'm not saying, yeah, you're an infinite being like this. Meditating about it, which is totally valid. I'm talking scientific method. I'm talking literally, physically. You can describe mathematically how you are an infinite being living inside of an infinite thing called the universe. which changes very much the perspective that I got when I was a kid, where I was told directly by an adult that I'm an insignificant blob of plasma and cells sitting on some insignificant rock, rotating around some random, not very large star that's in one of trillions of stars in a galaxy and among billions of galaxies. And so you're so insignificant, it doesn't really matter what you do. I might as well just kill myself right now. I mean, are we really telling kids that still? I don't think that's a good idea. I think we should start actually telling kids what we actually know. And us adults are way old school, behind the curve, right? We could barely even keep up with the information. I think kids today are like, what are you talking about? They already have this information inside them because they were born into a culture that genetically is holding this information and is gathering it collective learning style, and can look at the adults and be like, what? Nassim was one of these kids. And he's like, no, I don't buy it. I'm going to totally rewrite physics starting at age 9. And that's what he's been doing, right, for 30 years. So now we've got a guy who's saying something very different than the standard model. He's having a hard time getting published. But I have good news for you, which is A, Nassim Haramein just got a massive grant from a donor that has given him a foundation to rebuild his lab where he lives in Kauai. And he's hooked up with some very high-level physicists that have seen this whole picture and his problems and are trying to get him published in a peer-reviewed journal, which is hard to do when you don't have a PhD in physics and you are not part of any major organization or any university. People that make peer-reviewed journals make the rules about who gets to be in these things. So now Nassim's information is about to come out. And just to give you a sense of scale real quick, you think of the Earth as being big compared to Pluto, but it's not very big compared to Jupiter. But Jupiter is nothing compared to the sun. The sun is 99.98% of all the mass in our solar system in that one object. But guess what? The sun is a tiny star. It's not very big. These are individual stars. Now the sun is a pixel in size. Forget the Earth, you can't even see it anymore. These are individual stars in our galaxy, and we're talking trillions of stars. This is a very small slice of the overall scale that I'm talking about, just to give you a vague sense of how incredibly infinite these scales are, and how big these we're obviously not that close to the sun. But just yesterday, the largest solar flare of the summer happened. Right now, we're getting bombarded with massive amounts of energy, including a bunch of X-rays. So remember all the times you put that bib on the dentist and stuff? Don't worry about it. We're getting X-rayed like 10,000 times the dentist guy's machine. So what the sun does affects everything on Earth. We just discovered these vortices that come out of the magnetic sphere of our Earth, like these, black hole-looking structures that actually go directly from the Earth to the sun through the 96 million miles in between us. So we're just starting to get a grasp on what's going on, really. And the information is changing so quickly we can barely keep up with it. And so Nassim is sitting here gathering new information, trying to figure out where we went wrong with the standard model. Now, flash back to 20 years ago, Nassim shows up at a physics conference with Gravitation, written by Wheeler, Thorne, and Meissner in the 60s, and he goes to these guys who are advanced physicists and says, I'm trying to understand the standard model, and I want to know where we went wrong. And so, please, if you will, follow me through this. Now, can you imagine Paul Serac, the guy who started string theory, is sitting in the audience, and there's Nassim with this book, and they're like, yeah, we learned that in high school. That's like the Physics 101 Bible of gravity, right? That's where you get detailed information on Einstein's field equations. Finally, on page 719, they give you a model for the known universe. Literally, you guys, it's a guy blowing up a balloon with pennies glued to it. This is what we're teaching kids in first day physics class or whatever in the university down the street. And so we know that we think that the universe started out with this thing called the Big Bang, right? And before the Big Bang, there was nothing, right? And then all of a sudden, there was this fantastic explosion that came out of an infinitely small point in space called a singularity, right? Which is where all the dimensions started. Oh, really? The entire universe started as a singularity, and then all of a sudden, the universe was created, and space started happening. And it took a few seconds for subatomic particles starting to form, and it took a while. Then atoms started forming, and then I think, something like 380,000 years after the Big Bang, then stars started forming, right? Because there was this giant cloud, and where clumping started happening, there was a little more clumping, there was a little more gravity, and so gravity started to condensed these things until it became clusters of stuff, and then it became bigger stuff, and then stars formed, and now here we are, 13.75 billion years later. We just added 50 million years to the age of the universe. If you were 65 or older, you were told when you were a kid the universe was 3 billion years old, right? And then it became 7. Now we're 13.75 billion years. So here we are. Now what's happening? We're observing that the universe is expanding, and it's expanding faster and faster. It's called inflation. And the guy who figured this out and proved it won the Nobel Prize in Physics last year. And the pennies represent galaxies, and as the universe is expanding, the galaxies are moving away from each other. And so this is the model that we show kids. And so Nassim looks at this model, and he says to this group of physicists, he's like, can you please explain to me, what I really want to know is, who is this guy? And those guys were not laughing, you guys. It was more like, oh no, some guy's going to mention God in the physics department at Georgia Tech. Oh, what are we, you know? And Nassim's like, no, hold on a second. I'm actually not going to mention God. I'm going to mention for every action there's an equal and opposite reaction rate. Can you imagine Nassim saying this to Paul Serac? It's pretty solid logic, right? If this guy's blowing up a balloon, when the balloon expands, this guy's lungs have to contract. Have you heard about the big contraction? No. They're really good at explaining things that go away from the center, things that explode, right? Things that go out, electromagnetism, rockets, all male-based, right? Projectiles, right? Woo, let's shoot some stuff. Let's blow some stuff up. Let's look at everything. What about what's going to the center? Like, if the universe is expanding infinitely, faster and faster, there's got to be a hell of a lot of contraction going on, because the most foundational thing that we've ever figured out in physics is that no matter what we observe, we know there has to be something equal and opposite to that happening at the same time. It's the most foundational thing we know. It's pretty solid logic. Nassim's like, well, what's the big contraction? So this is where he started. And then he busts these guys even farther, because he's like, okay, you guys are making a lot of observations. You're coming up with a theory that's got all those equations, and you're collecting a bunch of data. What kind of data are you collecting? They're talking about light, heat, sound, X-rays, gamma rays, cosmic rays, microwaves, all these various frequencies of the electromagnetic spectrum. That's all great. Okay, cool. You're measuring it with your eyes and with telescopes. How are you even making those observations? If there was no stuff out there to measure, you wouldn't be able to measure anything. In other words, if there was no matter in the universe, there'd be nothing for light to hit, so it could bounce off and hit your eye or hit your telescope. And so you're like, okay, what's matter? What's mass? We have no idea what mass is or where it comes from. That's why we're so excited about the Higgs boson, because we think we figured out that there's this little particle that gives mass to everything. We don't know where charge comes from. We don't understand gravity. We don't understand mass. We basically understand very little. And we think that we're so smart and we've got it all figured out. And then time and again, we realize that we didn't have quite the model put together properly. And so Nassim's like, okay, you're making a bunch of observations on matter. What's matter? Well, there's a long debate about what that is, but we've found that all matter we've ever found, except for dark matter, which we haven't found yet, which I'll get to, is made of atoms. And then we're like, okay, what's an atom? There's a little bit of debate about the exact true nature of the atom, but we're pretty sure that all atoms are made of 99.999999% space. And there's only 0.000001% stuff, like protons, neutrons, and electrons. So if my fist is the size of a nucleus of an atom, the next closest nucleus is 4 miles away. That's how much space we're talking. If you're talking about the atom as the size of a football stadium, the nucleus is the size of a grain of sand in the center of the stadium. That's how much space is out there. So us, everything we see, our bodies, it's all made of a vast amount of space. So if you're going to come up with a unified field theory that describes the entire universe, you might want to pay attention to the 99.999999% part. These guys who have been observing the universe and making the Big Bang Theory and observing all these things, light, heat, sound, and all that stuff, the only reason you can make those measurements is due to the very small percentage of the space that we call physical stuff that gives us these measurements. So we're measuring 50% of what's going on, and of that we're measuring 0.00001% of what's going on and going, ta-da, here's our unified field theory that describes the entire universe. I don't think so. It seems more like we should pay attention to the space. What's up with the space? Is there structure to the space? Is there a density to the space? Is there a dynamic in the space? That's where Nassim started with his theory. So he had to go look at the nature of space. When we pointed the Hubble telescope at the blankest piece of sky we could find with nothing there, and we let light hit the telescope for 10 days, we realized that it was galaxies forever as far as we could see. And we had to change the age of the universe because we saw galaxies that were farther and farther away, closer to the Big Bang. I have a feeling the universe is going to get a little older as our technology evolves, but that'll have to play out. Now here's the thing that's tough. Have you ever heard about space being full? Space isn't empty. As a kid, I used to think, oh yeah, in the vacuum of space, you're floating around, there's no molecules, there's no atoms, there's nothing there. We did an experiment at Seattle University in 1990, and this has been verified many times since then. An experiment thought of by Casimir in 1947. Let's isolate a sliver of the vacuum of space and try to make it so that there's no electromagnetism in there, no frequencies of the electromagnetic spectrum in a vacuum chamber, and we'll measure the differential of pressure on the outside of the plates and on the inside of the plates. This is a very short layman's explanation of an experiment that basically, in the end, verified that space is not empty. It turns out that space is infinitely full. And you should all look at me very strangely right now. What do you mean? If we're floating in the vacuum of space and I move my hand like this, you're telling me I'm moving my hand through infinitely dense medium? An infinitely dense superfluid medium, if you will, called space? How come I don't feel that? I don't see or feel anything there. It seems like there's nothing there. That's a pretty major anomaly in physics, don't you think? That we've measured space to have an infinite amount of energy in it, these little tiny vacuum fluctuations. They used to call it the plenum, right? They called it the ether before Einstein. Now they started calling things like the zero-point field, the quantum foam, the vacuum, space. These are all different names for the same thing. Some people call that God. So what is really going on? How is it that space is infinitely full, but we perceive it as empty? And here's the crux of Nassim's entire theory. He thinks that space is so highly organized, so perfect in its structure, that it's creating an equilibrium state. A state where all things are canceled out, equal and opposite, as above, so below, creating a perfect balance that we call space. And then, in that space, there's a gradient of density, from infinitely dense down to very little density. And where you have a change in density, you get a dynamic happening in the space. For example, in our atmosphere, if you have one air mass that's one temperature and another that's only 2 degrees different, and they come up and they hit each other, what happens? It starts to spin, and you get a hurricane. Just from 2 degrees difference in the density of the medium that's there, called the atmosphere. Now imagine space, from infinitely dense to not dense. Anytime you get a change in gradient in density, you get this dynamic spin, hurricane-like structure happening in the space. And so Nassim starts to describe the universe in terms of that dynamic. That dynamic that I'm describing, which is a spiral dynamic going down towards stillness, like the eye of the hurricane, is a fundamental dynamic that we see on all scales. We see that in galaxies. There's a supermassive black hole in the center of the galaxy, and that's what the stars are spinning around. So Nassim's theory basically says that all those dots that I was talking about, all those different scalar dimensions of singularity, are different scalar dimensions of black hole. That the universe is made of nothing but black holes, from infinitely big black holes to infinitely small black holes. This should be another point where you look at me very confused, because you were told that a black hole is this mysteriously black funnel in the sky that you can't see, that sucks everything into it, and if you get too close to it and you cross the event horizon of the black hole, you have no choice but to get sucked into singularity, and then you disappear and go into another dimension or something, and we don't know what happens. Nassim redefines a black hole, a black/white hole, spelled W-H-O-L-E, because black holes, like everything else, have an equal and opposite. The information doesn't just go into the black hole, it also comes back out again. And the way a black hole looks depends on where you are in relation to the event horizon. If you're on the inside of the event horizon, the black hole might look black. Like tonight when you go out and you look up into the sky, it's black, which is pretty bizarre, isn't it? Considering there's trillions of galaxies with trillions of stars in it. Why isn't the sky completely white with light? Because there's so many stars. The short answer is we live inside of a black hole right now. It's called the universe. And light cannot escape from the event horizon of the universe. If you shine a laser into space, Einstein taught us it'll eventually get caught by gravitational fields and it'll curve right back into the universe. If you're on the outside of the event horizon of a black hole, you're going to see the information coming out. It's going to radiate, and you'll see it as an object. For example, the center of the galaxy. 20 years ago, Nassim predicted you'd find a supermassive black hole in the center of every galaxy in the universe, and he was kicked out of a physics conference for even saying that, because there was no evidence to back it up at the time. Now we know that every galaxy in the universe has a supermassive black hole in the center of it, and that's what's keeping the dynamic of the galaxy going. And then around the event horizon of the galaxy, of the supermassive black hole, shearing off that event horizon, come smaller black holes that spiral out away from that black hole, called stars. So for Nassim Haramein, every star in the universe is a black hole. Our sun is our local singularity. Thank you for being there, because if it wasn't there, we would not be here. And coming out of the black hole in the center of the sun, what's that doing? It's making smaller black holes. What happens in the center of stars? Matter production. Atoms are made. So Nassim has a paper that was published in 2009 that actually won an award at a physics conference in Belgium at Liège University called the Schwarzschild proton, which describes how the proton inside of every atom in the universe is actually a miniature black hole, a very, very small black hole. That an atom itself is a black hole. It's a scalar black hole. So he would also say that there's a black hole in the center of the Earth and inside every planet. And that's why the Earth is very, very gradually getting bigger and expanding. Have you heard of that hypothesis? Expanding Earth? Check that out on YouTube. See a computer model, if you squish the Earth to 65% of it the way it is now, all the continents fit together like a puzzle. And the whole Pangaea hypothesis of the continents breaking apart and floating to be evenly spaced doesn't make as much sense. And so he says that the universe is infinite scalar dimensions of black hole nested inside of each other. And they're all in these different scales. And the way that this works is that it's a dynamic inside of a superfluid medium that's infinitely dense called space. And where you get a gradient in the density, you get a dynamic, and you go, oh, look, there's a galaxy. Oh, look, there's a star. Oh, look, there's a planet. Oh, look, there's a subatomic particle. These are all scalar dimensions of the same dynamic, which is a spiral vortex going to stillness with singularity in the center of it. Singularity is in the center of everything, including you. And that all happens inside of space. And so Nassim said, well, maybe space has got a structure that's so equal and opposite, so perfect in its geometry, that it's canceling out that infinite density. We perceive it as nothing and call it space. But where you get a dynamic, then you go, oh, that's not just space. There's a little dynamic there. That's an atom. You put a bunch of atoms together, you get what we call matter and us, right? And planets and stars and galaxies and clusters of galaxies. And it's all scalar dimensions of this spiral dynamic going to stillness. And so he says, what geometry, what structure of the space would account for the fact that it's infinitely full, but we perceive it as nothing? It took us a while to figure this out, but Nassim found a quote in that book, Gravitation, where modern mainstream physics gets rid of this entire notion. We know, I'll have to read it, present-day quantum field theory gets rid by a renormalization process, it's called, of an energy density in the vacuum that would formally be infinite if not removed by this fancy word that we just made up. In other words, we know that space is infinitely full, but when we put the number that represents how dense space is into our equations, all our equations come out to infinity. And then what are we going to do? Make a press conference and get CNN to come? We've now have a major new scientific discovery. The universe is infinite. And then Wolf Blitzer's like, thanks, Lao Tzu. I thought we were going to talk about physics. You know what I mean? A physicist doesn't want to sound like a mystic. They want finite numbers. So what did they do? They just renormalized it. They put a constant in there, and they pretended like that number wasn't important, and they went on and got a unified field theory that didn't account for the fact that space is actually infinitely full with energy. That was a major, major error. This is something that Nassim is calling out. And so he goes about his business coming up with a unified field theory that describes the universe, keeping into account the fact that the vacuum is actually infinitely full. It's 10 to the 94 grams per cubic centimeter, the vacuum of energy density. If you squish the entire universe into a cubic centimeter, it would only weigh 10 to the 55th grams. I'm telling you that there's 39 orders of magnitude more density in empty space than if you squash the whole universe into a cubic centimeter. So I'm saying that space is infinitely dense. You can't even think of it. You can't even perceive it. And so he writes papers describing this on all scales. I don't have time to go into the scaling law, but basically all black holes have a relationship to each other, a linear relationship of frequency versus radius, and you get the phi ratio coming out of this data. Cells fall in the middle of that. You'll notice the cell bisects the scale. The cell is actually halfway in size between the smallest thing that we know of, which is called the Planck's distance, and the biggest thing that we know of, which is called the universe. I know you guys think of yourselves as small, but we're actually halfway in scale between the infinitely small and the infinitely big. That means that we potentially are the event horizon for the universe. All information passes through our scale. We observe the bigger and the smaller. We are the feedback loop of information for the universe to learn more about itself. We're at the very edge of the universe looking back inside the universe, feeding the universe more information. It's called biology. Nassim thinks biology is a very essential part of the universe. We are where the most information is being exchanged at the fastest rate, and we're obviously creating more coherency as time goes along, not less coherency. Because when I was a kid, if somebody had too many zeros in their phone number, you were bummed because your hand might fall. Am I dating myself right now? Your hand would fall out of the dial. Now I'm like, hold on, I got to update my Twitter status on the iPhone 4. That's some pretty organized matter in just my short lifetime, right? So we are obviously making the universe more organized as it goes along, not less organized. So it starts to give you a perspective of where we are in relation to the universe. Right away, in a short amount of time in Nassim's first lecture, he had me glued. I was like, I got to find this out. I saw Nassim for years, and eventually I thought I could kind of explain this stuff, and I went to him, is it okay if I explain this to people? He said, yes, I need help. I need somebody to do these talks for me so I could stay in my lab and do more research. That's how I got to be here. I've been trained by Nassim to do these talks. There's been about 84 people that have been trained to do this, and they're all over the world. I'm going to be doing longer presentations that are called the Delegate Program. It's weekend-long presentations. I'm doing one in Vancouver, British Columbia, August 17 to 19. And you can find out more information at various websites, which I'll tell you. So now Nassim looks at the geometry of space. He tries to figure out what's the geometry of the vacuum that would give you this perfect equilibrium that would neutralize this infinite density. And he started thinking about this when he was, teaching skiing in Whistler, and then going to Australia, and then going to Whistler. He was teaching skiing all the time, every season, until he got so sick and tired of freezing his butt off. He went to Mexico, and he saw Chichen Itza. And he thought, whoever built this knew some serious geometry, because at 5:41 p.m. on the equinox, the sun creates a shadow on the side of the pyramid that makes it look like a snake on that staircase. You can't just build this thing and then rotate it so that it'll do this. You had to know from stone one how to do that. In order to do that, you had to know where you were on the sphere, you had to know the angle of the sun, you had to know how the Earth went around the sun, you had to know a lot of pretty advanced mathematics and physics and astronomical, cosmological information. So he thought, well, maybe there's a clue as to the geometry of the structure of the vacuum of space by looking at the geometry of ancient cultures' architecture, which kind of makes sense. But you don't really get modern physicists looking at this kind of thing very often. But this is the line of reasoning that led Nassim to look at this stuff. And he looked at all these various pyramids in Mexico and all around the world. And it seems like what they're trying to tell us is there's an important relationship between a sphere and a tetrahedron. If you put a tetrahedron inside of a sphere, and it perfectly fits, one point hits one of the poles, and the other 3 points intersect the sphere exactly at 19.47 degrees latitude. And you divided your sphere 1/3 above and 2/3 below exactly. You could do another tetrahedron in there and get another 19.47 on the other. If you do that inside the Earth, you'll notice the big island of Hawaii is exactly on that line, and that's where the largest mountain, largest volcano on the planet is. It's also where the red spot is on Jupiter. It's also where there's increased sunspot activity on the sun. There's a lot of important things that happen at this 19.47 degree. And this is something that ancient cultures around the world all knew because they all built pyramids. This stuff is starting to come out really quick, and I only have 5 minutes left. So I'm going to be able to get to the structure of the geometry of the vacuum, but I'm not going to be able to get to all the ancient culture stuff and how they all knew this. If you want to know more about that stuff, there's a couple of really great sources. I used to stick my neck out, I used to think, when I started talking about extraterrestrials in these talks. Now, people are like, yeah, I've seen every episode of Ancient Aliens. It's okay, you don't need it. Have you guys seen Ancient Aliens on History Channel? Oh my God, you guys haven't seen this stuff? Whoo! Do yourself a favor, go to Netflix or YouTube and look up Ancient Aliens. It's a mainstream program with mainstream advertisers spending lots of money to advertise during a program on History Channel, which means it's basic cable, which means 250 million Americans have access to this information, that aliens obviously exist, They've obviously been here for a long time. They obviously gave information to ancient cultures. And I used to think that, like, people look at me like, what? Now people are like, yeah. But long story short, do yourself a favor, open up yourself to the fact that you live in a galaxy. You're a member of a community because by definition, you're a galactic being because you live in a galaxy. And we're not the only beings in the galaxy. If you have a hard time with this, keep looking into it until you get to the point where you realize that we're not alone in the universe, that there are other biological entities other than us in the entire universe, and that they're very well aware of every last thing that's going on down here, and they're checking us out. And they have been for a long time. And they came here a long time ago and gave us all kinds of information. And the proof is in things like the Great Pyramid of Giza and all these other pyramids that are all around the world that have the same geometry, no matter what culture you're looking at. This is a long part of the talk that I usually take 2 hours to do, that I just did in about 3 minutes. And I won't have time to get into that stuff, but I'm telling you now to go back and go to the internet and start researching this stuff, and all your doubts will hopefully get shredded down until you're beyond a reasonable doubt and you realize that aliens exist. Alien's a bad word because we're aliens to anybody who's not from this planet. Call them whatever you want. Galactic family is a good one. Because we are. We're part of a family. Whether you know it or not yet, we're part of a family, and we're like the toddlers, maybe. It's more like we're infants, right? They've been watching us for a long time. Nassim looks into the geometry of space. He's trying to find the perfect geometry that would explain perfect equilibrium, and I'm going to have to cut to the chase and tell you that if you take 2 of these isotropic vector metrics, which was invented by Buckminster Fuller, with 20 tetrahedrons in each, and you put them together like this, you get a star tetrahedron with a geometry on the inside that is a perfect vector equilibrium in 3 dimensions. It's called the cube octahedron. It's 8 tetrahedrons pointing into a single point with 12 radial vectors coming out. All those radial vectors are exactly the same length as all the edges. So all the lines in that red geometry are all the same length. It's a perfect balanced 3-dimensional vector equilibrium. It's the only geometry that does that. It's called a cube octahedron. That's the kind of geometry you'd be looking for that would create a perfect balance in space and cancel out the infinite density of the vacuum so that you could perceive it as nothing. So then you're like, okay, is the universe one giant cube octahedron? No, it's got to be a geometry that's scalar. It's got to be a fractal. It's got to get infinitely bigger and infinitely smaller. So how do you get to fractal levels of cube octahedron? You start adding more tetrahedrons to the outside of a star tetrahedron. You already have 40 tetrahedrons. You add 24 more to the outside of it, and you eventually get to this thing that is 64 tetrahedrons. I'm skipping over the 2-dimensional vector equilibrium because we don't have time. A hexagon is a 2-dimensional vector equilibrium. You put a bunch of those together, you get a 3D version. And then when you add more tetrahedrons to the outside, eventually you get to this, a 64 tetrahedron grid. This is Nassim Haramein's theorized geometry for the fabric of the vacuum of the universe. Okay, good. Phew. I was just making sure there was no earthquake, because if you go to YouTube and you look up unified field theory earthquake, you'll see a picture of me sitting on a stool with this picture. Usually it takes me an hour and 45 minutes to get to this slide, by the way. I just did it in 55 minutes. And then I say, this is the geometry of the vacuum. And right then, a 4.7 magnitude earthquake happened exactly at that moment. And you see me go. And then everybody sits down because it was just tremors, you know, and then they applaud and laugh and they go, how did you do that? And you see me going. I'm like, don't look at me. It wasn't me. That's obviously how it is, right? Biggest coincidence of my life. On YouTube, it's proof, right? So I was like, okay, I give up. I was like, I have no idea how I got to be this person talking about this stuff, but obviously something is going the way it's supposed to be going, or else that earthquake wouldn't have hit right then. 10 seconds earlier or 10 seconds later, it wouldn't have been nearly as dramatic. It was the exact instant where I got to this and said, this is the geometry of space. And the universe was like, yes. And so why is 64 important? Because when you get to 64, you get a cube octahedron inside of a cube octahedron. It's the beginning of an infinite fractal series of space-time dividing, giving you infinite scalar cube octahedron geometry. Perfect vector equilibrium at all scales. You need at least 64 of these things to begin to get there. Luckily, I don't have much time, but I can show you that it's a 3-dimensional structure. We're not talking about a 2-dimensional thing. This is 64 tetrahedrons. And it's just the seed geometry of the vacuum. It's actually infinite tetrahedral array. This is Nassim's theory. And when you look at the 64 tetrahedron grid and this geometry, you can start to get all the information of the universe out of this. Every language, every history of every culture on the planet is referring to this. It sounds pretty out there, but if you start looking at things like the Mayan calendar, the I Ching, the Torah, the Quran, the flower of life, the tree of life, the Kabbalistic tradition, it doesn't matter where you look, it is all sourcing back to this same set of information. It's geometry. It comes down to the structure in space. There's nothing in the universe that isn't inside the structure of space. And so if you look at the geometry of the vacuum and you start to compare it to all these other informational systems, you realize that it all comes down to this. 8 star tetrahedrons pushed together gives you a 64 tetrahedron grid. 1, 2, 3, 4, 5, 6 forms the 7th in the middle, and the pattern repeats like an octave. Like in music, you have a note, you go up 7 notes, you get to the next octave. This is an analogous thing happening in the structure of space. And inside of all this, you get these dynamics that are the spiral vortex going to singularity, causing black holes. And so this is where Nassim goes. He starts to show that everything is a black hole, everything has a black hole in the center of it. He starts to look at how this information relates to ancient cultures. And before you leave, the most important thing for me to get to is us. Here we are in a yoga conference. And so I can sit like this and put my hands like this and then go like this, and you guys all know what's going on, right? Many people have been trying to tell people to sit like this. Why would you want to sit like this? What shape am I making my body into? A tetrahedron. If you want to glean information directly from the universe, maybe it would be a good idea to put your physical body into the geometry of the foundation structure of the universe. In other words, put your hands like this and make yourself into a tetrahedron. And then while you're at it, act like a black hole, right? Where information comes in and it goes out. Like take the universe in and then push the universe out and do this continuous feedback loop of information like all black holes do. Something like, oh, that's why they told me to sit like that and breathe. Now I'm acting like the universe. I'm tapping into the fundamental structure and dynamic of the universe. And when you do that, you know what happens. You start to center yourself, literally. You could find where your center is so you realize how spun out you got last night. You try to bring yourself back really quickly before you have to talk about unified field theory at 10 in the morning. And you have to play a gig in an hour. I'm playing a set of music at 12:30 over here on this stage. And so I don't have a lot of time. I've now reached 3 minutes after 11. I'm supposed to stop at 11. I do have a few more minutes, but this is the fundamental thing that you need to leave here with, is that if there's any one thing that you take out of the unified field theory lecture, it's actually to check in with your own personalized singularity every day, even if it's for 30 seconds. Some of you, I have a feeling, might do this for like an hour a day or more. Out of all the groups that I ever talked to, the Wanderlust yoga conference, unified field theory talk people are some of the most resonant people probably on the planet, I would say. I'd say you guys are very important seed human beings on the planet right now. Not everybody is coming to these kinds of things. Not everybody is interested and seeking out this kind of information. And so I'm not just here to go blah, 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 so you could be like, oh, cool, that was nice. Thanks. I'm here so that you will go back out there and somebody will be like, I thought we were going to have breakfast. Where were you? Oh, I was at this lecture, Unified Field Theory. Jamie Janover talking about the work of Nassim Haramein. What? What's that? What's that? What did he say? You guys will be like, But what are you going to say? Try to explain this to somebody and they'll be like, oh yeah, I was just looking at YouTube. I saw that guy. This relates to Melchizedek and the flower of life thing, and it relates to Stephen Hawking, and I know about Einstein a little bit. And then you start talking, and man, you can get this really going. So I'm here to try to remind you how important you are as an infinite being inside of an infinite universe, sending information out and taking it in, and checking in with your own personalized singularity, whether it be music, yoga, dance, making love, playing drums, I don't care what it is, anything that is a meditative process, if you will, that checks you in with your center, helps you to understand the entire universe. Because inside of singularity, inside of that stillness, is all the information of the entire universe. Every point in the entire universe is connected to every other point in the entire universe by that one thing that's everywhere, no matter where you go, called space. And it has a fundamental structure and a fundamental dynamic. And through that, you physically, literally have an effect on the entire universe from your resonating center, from the black hole in the center of your existence. The Buddhists call it the Bindu point, right? You've seen Buddha hanging out like this with the Kundalini vortex looking like a black hole going through your crown chakra until it gets smaller and smaller and smaller. And it gets to that center of your heart, the Bindu point. The Bindu point is your singularity. In physics terms, you could call your Bindu point your black hole. You guys all have a black hole in the center of your existence, radiating out, making a very specific dynamic. And that dynamic is the dynamic of all black holes. And that's what I should leave you with. Now, I don't have time for the whole crop circle section, but the crop circles that come down basically are mapping out this geometry in every possible way, including the dynamics. The crop circles that have been happening in the last week or two are pretty amazing. Star tetrahedron ones, really great ones, are just happening like now. My friend just put a picture on Facebook of her standing in one yesterday that was really cool. It's coming at a massive rate. Starts to show spin is important. Starts spinning geometry, you might be able to get some power out of it. So maybe we should start looking. So when Nassim started talking about crop circles, after talking about all this geometry, I was like, what? I thought you were a physicist. Now you're talking about extraterrestrials? What? So that's Stonehenge in the upper. It's just over and over, these crop circles are getting more and more complex, showing this dynamic and this geometry in every possible way. Stuff like pi, mathematical concepts. I'm just trying to get through all these crop circle shots so I can get to the, there's a 64 tetrahedron grid with the spheres on the inside. If you put spheres around all these tetrahedrons, you get a three-dimensional flower of life symbol. The flower of life symbol is found in cultures around the planet. I'd check out Drenville and Melchizedek's work. Ancient Secrets of the Flower of Life is a great book to check out. It's the more esoteric, philosophical, informational systems related to this geometry. And Nassim's going more into the physics of it, but it's all complementary. It's all the same thing, obviously. Yeah, let's go out, drink some beers, get some boards, just mush down some crops, make a good hoax. People think the aliens came. No problem. Oh, dude, you messed up. We got to prop up some crops we already laid down. Now they're going to know as a hoax. Damn. So yeah, the whole story of the kids running into the field, I don't buy it, Even the graffiti artist aliens know they have to work within the structure of space-time, It all relates to that same geometry. Even if it looks like it's not, it is. That showed up on 8808. Spin is important. Nassim knows this. This is a very important animation that everybody on the planet should be shown as a kid. It's the actual dynamic of our solar system, showing that the sun is moving through space. It's not just sitting there. You shouldn't tell kids that the Earth goes around like this in a circle. We're making a giant phi spiral right now, just like the DNA molecule, which encodes all of your genetic history. That's because the DNA molecule leaves an imprint on the structure of space-time. Google phantom DNA, discovered by a Russian researcher. It's another good one. Spiral dynamics is all we have. Everything is spinning. Nothing is not spinning. It's all spinning towards stillness, all going to singularity on all scales. And this is the way you start to describe the universe, no matter where you are. And then it starts to relate to all the ancient information. And when you put this spin into Einstein's field equations, which is what Nassim did, he added a torque term to Einstein's field equations and got the vacuum to curl instead of just curving, right? Einstein said space-time curves to infinity. It's actually curling like water going down the drain. That's why everything's spinning right now. Because the universe is curling to singularity at every point, causing singularity to happen, causing a continuous medium of superfluid, highly dense stuff that we call space, which is actually a fabric of singularity. And that is what I think that they're starting to discover with this Hadron Collider. The God particle should probably be described as, oh, we've discovered the vacuum. We've discovered space. We discovered that it goes infinite. And that Higgs boson is not the end. If you made a bigger accelerator and you knocked smaller things together, you'd get another thing. And it goes infinitely smaller, infinitely higher energies. We're just starting to describe this in the standard model. And I have a feeling down the line, they're going to be like, wait a minute, this guy Nassim Haramein, that crazy guy that was talking about crop circles 20 years ago, he had this all figured out. It actually comes down to the geometry of space-time and the dynamics that happen in it. And the ancient cultures knew this because they got downloaded by the galactic family tens of thousands of years ago. What? Yeah. I'm here to tell you, yes. I have a feeling this is all going to work out and that we're going to find out that that's how it goes. Time will tell. We're not exactly sure right now about these things, but I have a feeling that's where it's heading. When I first saw this stuff, I was like, okay, my life is now totally different than what it was before. Now, instead of just doing these things that I thought I was going to do, now I know I'm going to have to spend a lot of time in the rest of my life talking about this. So now I'm doing this all over the world. I've done these talks in many countries. I'm doing weekend-long talks now. I'll be going to Romania. I'll be going to South Africa. I'll be going to Brazil. I'm doing one in Vancouver, British Columbia. I'll be going to Australia later in this year. I did a talk like this earlier in Bali. I did one in New Zealand. So I'm like going all over the place, trying to get this word out and letting it go exponential. I'm working on a film called Infinite Realms, the Unified Field. I did a Kickstarter campaign, and I'm trying to do a 20-minute YouTube video that condenses down what I just said into 20 minutes using imagery, moving imagery, and narration, to try to get it so that a sub-Saharan teenage girl that doesn't speak English can look at this YouTube video and be like, oh, the spiral dynamic of my cactus outside my door is the same as the galaxy, which is the same as the atom, which is the same as everything else. Oh, I see how it works. Just using imagery and geometry and stuff like that. I feel like it's a very important process to get this out into the vacuum right away in our local area here in our coherency called Earth. And I think that it's very important that we do it right now as fast as possible. And that's what's happening, luckily. And I think it's pretty high drama down here. Actually, I have a personal theory, which is that the Earth is actually a gigantic reality television show for the galactic family. What's on today, honey? It's reruns. It's still the 7 billion Stooges. Over and over, they're beating each other over the head with 2x4s because my book says this and your book says that, so I'm going to fucking kill you. It sounds ridiculous, doesn't it? That's what's happening right now. It's got to stop, you guys. Like, seriously. We got to stop sending bombs over walls and stuff. If I could just get a whole room full of people, just like you, that are all physicists, that are also all members of, the most extreme religious, fanatical fundamentalists out there. It doesn't matter what religion you're talking about. And then I can go through all this stuff and show how all this geometry relates to every religion and get one of these guys to go, oh my God, the Torah and the Quran came from the same set of information, interpreted in different ways. Whoops, sorry. You guys pray like that, and we'll pray like this, and we'll stop sending the bombs over the wall, and we'll just make it into one giant festival where we celebrate each religion like we celebrate styles of music, and we can make this whole place into Festival Earth. Thank you, guys.